All right, good morning, 3B. Now, please retrieve the two files at the Google Classroom. Okay, click the Google Classroom and retrieve the file. Now you may turn on the camera and let me know you have been there, right here. Now the page we're just referring to is on here, right? I just uploaded onto the Google Classroom. Now please make sure you have got the file. And we will start the lesson very shortly. Some students, you better comb your hair. For example, I don't want to give some example, but some of you didn't comb your hair before you come to the classroom. 唉，梳頭啊，唔該，上堂早少少起身啊，咁搞笑嘅你個頭嚇。Number 7. Number 7, could you please turn on the camera? Let me know you are here. 20 梁柏佢要 feel so cold. 做乜鬼 ？You're indoor 做咩好凍咩？搞錯啊！真係，唉。黃正滔、歐家權，number 3 and 21. Could you please turn on the camera? Let me know you. Now double check if all of you are here. Have you all downloaded the notes? Okay. Now in this lesson, in the following lesson, we will tend to use the notes instead of the book, because you know that since for the first lesson of the chemistry, you know that I have added more information to this, so you better rely on the book, the notes instead. So the book is just the word, the supporting tools. Okay, is that clear? 1, 2, 3, 4. Number 5. Number 27. Not here. 2, 3, 4. Number 5. Number 5 here. Number 5. Number 5. 27. 5號陳俊軒喺唔喺度？陳俊軒有冇見到陳俊軒啊？27伍家宏啱啱到，咁啊爭5號啫，係咪？幫我睇下係咪？冇嘛？係得。好，we start the lesson now. Now, so you would refer to this plastics. So plastics is a very important materials in our daily life. Okay, very, very important materials nowadays. So to start with, can you please read that few pages, okay, from page 27. Okay, today we focus on 27, and try your best to fill in those information first of all before we start. Okay, I need to get back my writing pen. So sorry about that. Spend some minutes on that. Now, plastics is a very important materials nowadays. I must say that every day you would need to you touch at least one plastic products. Okay, but you may find but plastic is just, we call it plastic. We have got so many different types of plastic. According to the different uses and the properties, we will use different plastic, just like metal, right? Metal is not just metal. If you go into detail, there are so many different types of metal, similarly as plastic. So most organic compound, most raw materials that to be found for making plastic, they're derived from, what is that? In your boiling point fraction, right? Of the fractional distillation of crude oil, 石路油. Recall your memory. Where is 石路油? It's on here, okay? It's on here, naphtha. So this is about C7 to C10, okay, hydrocarbon. So not too big, not too small. It is a raw materials for production of plastics. And naphtha, but it is not the real raw material. We need to do something in order to become the raw materials. So it is done by the procedure. We call it cracking. Cracking, 裂解. Okay, so for example, if you see that diagram, you can get what I mean. Now, and if in the naphtha, we have got how many carbons are there? 1, 2, 3, 4, 5, 6, 7, 8, about C8 carbon here. So after cracking, you can break it down into the smaller pieces. while the smaller pieces, one of them it is the raw materials for making the polymer. Okay, it's for making the plastics. So what are the conditions? Well, first of all, you are going to heat it at the high temperature. Okay, only by high temperature you can break down those solid lines. So what is the solid line? A type of chemical combination. Do you still remember the term chemical combination? We call that bond. Bond of very strong attraction. So you need high temperature to break it down. Second is about absence of air. Now, why do we need to do it absence of air? Now, while you heat it, well, you know that it is also a type of fuel. If you heat it in the presence of oxygen, what will happen? Okay, you will burn. Okay, you will burn. So never heat it in the presence of oxygen in air. Otherwise, those materials, indeed it is also a fuel, will also be burned. Can you get the point? So high temperature to absence of air. Now afterwards, what will happen? They will be broken down into smaller pieces, so smaller hydrocarbon molecules, and one of them it is the raw materials. We call it ethene, ethene 乙烯. Now a very strange term to all of you, E, which means two, in, which means we have got a very strong combination. So with a very strange formula like this. Okay, so if you see that we have got single solid line, which means that a type of attraction. How about the double line in between? It is a much stronger attraction. Okay, these two is a stronger, much stronger attraction. So are very strange substances. So you need this one as a starch to produce the polymer. So as said before, I want to repeat once again, what's that? So first of all, I break it down into smaller pieces. Number two, right? Assuming you have got this one, and then you are going to further breaking down in other places, just like I spot this one as an example, and what you can get what I mean. We have got three here. Okay, and also we have got this one, four. We have got another four here. Can you get the point? Now, of course, this type of process, the chopping, right? The chopping of those molecule can they can be of different places. For example, like this. Now I pick up another one, and also like this. I'll let it show you here, right? And just inside W, and we have got five carbon atom that next to it. So can you get a point? So what is the hidden message? That the chopping, right? The breaking of those bond in the whole molecule can be done in different places. So simply speaking, Nafla is just a mixture of shorter molecule chains, but after cracking, you can make much shorter hydrocarbon. And this is the starting materials for making polymer. So what's next? What's next? Under suitable conditions, thousands of the ethene, you will see that thousands, right? So many of ethene molecules that will join together to form a very, I miss out the word, very large molecule, or we call that macromolecules, 巨大分子. And for example, we call it polyethylene, 聚氣. So this is what you may know it as, we will call it as plastics. Plastics, they are said to be a macromolecules, big molecules. They are made up of so many small molecules. Okay, what I want to tell you is that ethene is an example. They would join it repeatedly. repeatedly like this. Okay, finally it will turn a substance, we call that polymers. So the whole process we call that polymerization. Polymerization. Now somebody may find difficult to understand those terms. I would like to give you some definition of the terms. For example, this one. Now you may see that all those we have got so many basic unit, right? This is the basic unit. So n, so many, okay? N basic unit. So the basic unit, we call that monomer, 單體. Okay, so after doing that polymerization, so what is the hidden message? You are going to combine them one by one. Combine them one by one. And finally, what will be formed? We will call it a long chain with so many monomers joined repeatedly. So if you say that many is not mono, right? Mono is always referred to one. We have got many. I changed the word from mono to poly. Now you may heard of the poly in mathematics, right? Which means many. So this type of process, we will call it as polymerization. Polymerization, the process which turns so many small molecules to a big molecule. While the big molecule, we call that macromolecule. 巨大 macro 大嘅，唔係 macro 啊，係 macro，macro。Macro is MARCO, right? So it is different. Okay, can you get what I mean? Now, if you still find it difficult to understand, I would like to show you this the video, okay? And try to see it in graphical term, in graphically what is happening.
Polyethylene, PVC and polystyrene are polymers, also known as plastics. They are all being produced with the help of Nourion's organic peroxides via a process called free radical polymerization. Let's take a closer look at how this polymerization process works and what these plastics have in common. Since polyethylene is one of the most common polymers, we will use this as an example.
Now, I would like to tell you, they just mentioned three terms: polyethylene, PVC, and polystyrene. What are they? So indeed, polyethylene is what you know it in, as polyethylene. It gives you the same meaning as the term polyethylene in on your notes. Okay, please mark it down. Polystyrene, okay, you will know it in your notes. You have to search for me what are the uses of polystyrene. How about this? PVC. PVC, we have got a very long name. We call it polyvinyl chloride. So what are they in common? Once I read out those three terms, what are they in common? You may see the term poly. Poly. Can you see that? Poly. So which means that poly means many, right? So many things that combine with each other. So what are the monomers? The monomers, the name of it is very simple. Please check this, and this underlined in pink. Can you see that? So they are the monomer. They are just the monomers. Okay, the name of monomers. We call it ethene, vinyl chloride, and styrene respectively. Okay, now don't worry, the naming system is very funny. They simply add it as a poly, and that's it. Okay, so I will try to continue.
The raw material used in the process is ethylene, which is the monomer in this case. While monomer means one part, polymer means many parts. So polyethylene basically means many ethylene parts. But how do we get from one part to many parts? It actually takes 3 steps. The first step in the polymerization process is the initiation. When heated, the organic peroxide breaks apart in 2 radicals. These radicals start the reaction with ethylene. One free radical opens the double bond of an ethylene molecule and forms a new radical. Then this new radical opens another ethylene monomer, and this process continues, making the actual polymer. This second step is called the propagation. Now there's only one step to go to turn a monomer into a polymer, the termination. The polymerization reaction stops once the last radical on one polymer chain meets another chain with a free radical. Then they combine, and the polyethylene is finished. The production of PVC and polystyrene follows a similar reaction. Only the monomer, process temperature, and pressure are different. The production of PVC starts with the monomer vinyl chloride. The difference between an ethylene and vinyl chloride is that one of the hydrogen atoms is replaced by a chlorine atom. For polystyrene, the monomer is styrene, and here the difference is that one of the hydrogen atoms on the ethylene is replaced by a so-called phenyl group. We have just shown that while these 3 important polymers are different in composition, they all share the same origin. Neurion, we help make polymers.
Okay, so you will just get to know the brief, the overview of the making of polymers. Okay, we call that, what is the process? We call that polymerization. Okay, polymerization. And you may see, it seems like what? It seems like having a paper clip, okay? So many paper clip, they try to link it with each other. Okay, you may have got one analogy like this. Okay, we have got so many paper clips. Okay, paper clips, so we have got paper clips. Now that symbolize the monomers. So polymerization seems like I link those paper clip one by one. Okay, can you get the point? To form a polymer. While plastic is what we are mentioning like here, it is what we are having as plastics. Okay, is that clear? Can you get my point? Okay, so if you are going to do that experiments to produce polymer, is it possible? Can we do such? Can we do such action at our school lab? The answer is yes. You can do. You can do such action to produce the plastic at our school lab. Okay, but sorry to say that we still don't have. We still don't have it. We still don't have the chance of doing the lab. Okay.
Pour 20 cubic centimeters of styrene slowly into a clean, dry paper cup.
So you may see the raw material. It seems like glue, right? A very sticky liquid, colorless liquid. We call it styrene.
Add 8 drops of initiator to styrene.
Now, styrene, what is that? Styrene, it is the initiator is the reaction that helps to start the reaction. Okay,
Stir the mixture slowly with a wooden stick. Avoid forming bubbles in the mixture. Add 8 drops of hardener to the mixture and stir continuously. The hardener can increase the hardness of the polymer.
硬化劑 hardener.
During stirring, what do you observe about the mixture? Touch the paper cup with your hands. What do you feel? When the mixture becomes viscous enough, put the small objects you collected into the paper cup. Cover the paper cup with the lid. Keep the paper cup completely still for 30 minutes. After 30 minutes, tear the paper cup off the product. Describe the appearance of the plastic formed.
So what is that? What is that? What is that plastic? Okay, what is that plastic? We call that polystyrene. Which one is polystyrene? Okay, how you know? Now this is the crystal clear structure. Okay, so we call that in a lab we call it 水晶膠. Have you ever heard of the term 水晶膠? Now polystyrene is on here. Okay, polystyrene. So with the abbreviation PS. Okay, it is a clear structure, like it was once used as a CD cases. Of course, nowadays you don't have it. And also we have got disposable plastic foam food container. So we call this one a very special manufacturing process. We call that expanded polystyrene. Or you use the word foam to tell, foam plastic, 發泡膠. Okay, foam plastic. So expand, how you make that expanded is by bubbling. It's by bubbling those, while we make that plastic, we bubble it. We bubble it with air. And we try to have some air bubbles trapped inside that. So what is the use of this? It is a very good heat insulator to keep the food or drinks warm. Okay, so you know the air and plastic also both, they are a very poor heat conductor. Okay, it will help insulate the heat. It will reduce heat loss. Can you get a point? One more plastic we've just mentioned. To make shampoo bottles, detergent bottle soft, a type of soft plastic bags, or the cling film, 一啲保鮮紙啊. So what is that? We call that PE. We call that polyethylene. So in Chinese, very strange name, we call that 聚乙烯. While the polystyrene, we call that 聚苯乙烯. Okay, now I will give you one more task, right? Go home and please finish the remaining. Okay, tell me what are those plastics are. What are those plastics? And give me the name. Give them based on the uses and based on the properties they would have. Okay, please tell me which is which. Can you get the point? Okay, so I would like to make a conclusion of today's lesson. Now, first of all, plastic, you know, that is very important materials. The raw materials for making it is naphtha. So after cracking, we have got the raw materials. The raw materials, we call it monomers. Now we'll do some action to join them repeatedly to form polymers. Here comes 2 examples, polyethylene and polystyrene. Questions? Before you leave, could you please put the numbers to tell me your understanding before you leave? Thank you. Clement Chan, Why are you so late today? Clement Chan. Now you just entered just at 8:55. Too late. So you better, you better set the alarm function of your clock before you leave. Okay. Now it's time to leave. See you guys. Freebie. Bye-bye.